Before we start animating our bouncing ball, one of the most important things you have to understand is interpolation, timing, and spacing. Timing and spacing are two of the 12 principles of animation. Interpolation is quite new since it's the computer that is doing the interpolation between two keyframes, while in the past they used to animate everything by hand, adding drawings and drawings. Timing is the pace. It's the moment when the ball leaves the ground, is up in the sky, and then hit back the ground. It is defined by the key moment of the animation, or the extreme high position and the extreme low position in this case. We have a timing of 12 frames to get to the highest position and 12 frames to get back on the ground. Spacing is the difference of position of our sphere from one frame to the other. We can easily display the spacing by going into the object option, motion path, set the frame from 0 to 24 and click calculate. Blender will create a curve that goes through different points that mark the position of the origin of our sphere on each keyframe. The distance between those points is our spacing. And this spacing is based on the timing of our animation and the interpolation between two keyframes. By default, Blender interpolation is set to Bezier. What it does is that it creates an acceleration when the object is moving from a keyframe and a deceleration when it's arriving on the next keyframe. These are known as easing out and easing in, meaning that you are easing out of the keyframe, leaving it through an acceleration, and you are easing into the next keyframe, slowing down before reaching or hitting its position. So basically, we start with a very slow motion and it accelerates along the way. On frame 12, it will reach its maximum speed, so the spacing will be the biggest. And when it will come close to frame 24, it will slow down. This is what the Bezier interpolation does by default. We can change the interpolation mode by selecting all the keyframes with A and pressing the T key. It will open the interpolation panel where we can choose which interpolation our keyframe will be using. There are a lot of different pre-made interpolation, but we only need to focus on the very first one. To be perfectly honest, I never used all the others, but they can be very useful if you want to build fast motion for motion design, for example. But in our case, we will be mostly working using those three during the course. Let's select the linear interpolation. As soon as I will select it, the behavior of the ball will change and we will get a more robotic movement. In the Motion Path tab, I will click the Update Path, and now we can see that the spacing between the different frames is always the same. The spacing is even. If we now compare linear and Bezier interpolation, we can see that the timing is the same. They reach the lowest and highest point at the same time, but on the Bezier we have a variation of the spacing, so we have a variation of the speed of the ball, while in linear it's constant. The linear interpolation is very useful for robotic moves or for walk cycles, for example, when the foot is on the ground. Back to our motion, I will select all the key, press the T shortcut and set it to constant. I will update the path, and now we can see that the ball is changing position only when it reaches the next keyframe. So it's considered a constant interpolation or no interpolation, and it's perfect to focus on the timing of your animation. This is the kind of interpolation we use when we are blocking the animation. In most animation, blocking is the first stage, and it's very important. And we will start blocking our bouncing ball animation in the next video. Stepped interpolation can also be very useful whenever you want to give a stop motion style to your animation, like on this example. To summarize, we have seen that interpolation occurs between two keyframes, that we can change the interpolation mode using the T key, that the Bezier interpolation allows acceleration and deceleration, or easing in and easing out, that the linear interpolation has a constant speed, while the constant interpolation doesn't show any interpolation and is good to check out your timing.